Another solution which is often considered a security boundary or a security technology is kernel mode code signing. This technology disables loading a driver that hasn't been digitally signed in 64-bit Windows systems. This constituted a rather serious vulnerability from the beginnings of the system, ever since Windows 95. The problem was that the majority of critical errors, blue screens, were a result of an unstable driver. Drivers usually operate in the kernel mode and so have direct control over devices. A driver bug causes the entire system to halt. From a user's perspective, it seems like a question of Windows malfunctioning. This had to be fixed somehow. While moving to a 64-bit environment, servers today are all exclusively 64-bit, as will client systems be in the future. Microsoft decided to sort the situation. Effective troubleshooting requires identifying a driver's manufacturer first. The manufacturer can then be told how to fix the bugs. If a program is not signed, contact is nearly impossible. Many modules in a program's code don't contain any fingerprinting or contact information. And even if they do, the information is arbitrary. A digital signature using a certificate allows a clear identification of a software creator. How does kernel mode code signing work? At the system start, a list of revoked and blocked drivers is loaded. This is something along the lines of an exclusion list. If a driver can be found on a list, an attempt to load it will be blocked. This solution employs an interesting idea. The future of operating systems will probably involve granting explicit permissions to launch some programs. All applications will be blocked by default. The history of firewalls was much like this. Firewalls used to explicitly allow all traffic. Microsoft would release, for example, a security bulletin on dealing with the slammer worm that advised users to block port 137 in parameter firewalls. And people would do this. It seemed that 10 to 15 years ago, all ports were open by default and only selected ports were blocked. Today, it's the other way around. All ports are closed and only selected ports are open. The same solution could be employed for software. Let's return to kernel mode code signing. Before a driver is launched, its signature is verified. The signature has to be valid. The procedure also verifies whether a certificate was used for the signing of the driver has been issued by an appropriate certification center. A certificate costs about $100. It's not about entering a loyalty reward scheme. The goal is to uniquely identify a program's manufacturer. Kernel mode code signing has also been a target for attackers. An attack that got a lot of attention was one that was run by Joanna Rutkowska, who became quite well known after that. Kernel mode code signing is not a rogue driver-proof technology. To run an attack of this type, it's enough to purchase an appropriate certificate. The technology doesn't offer a feature for blocking modification of disk files either. Another solution that is often seen as a security technology, and which was initially marketed by Microsoft as such, is user account control. We'll dedicate one of the next modules to it, but let's now try to find out if this technology really defines a system security boundary. User account control aims to ensure that programs aren't run with escalated permissions, administrator privileges. – Even the programs launched by an administrator shouldn't be excluded from this rule. We've just had to explicitly allow a program to gain administrator privileges. Attempting to launch a process will display a pop-up box asking if you really want to run it, and the whole screen will be grayed out. If you wait long enough, you'll see, for example, that the system clock has stopped. The background image is a bitmap of the current screen. All these operations are there to make you take notice of a security-critical question. To return to your work, you need to react in some way to the displayed message. Since you haven't pressed Ctrl-Alt-Delete, the prompt could have been displayed by any process. It's easy to create a program that will display a question that looks like a legitimate system warning. If another process displays the window, a standard user will be asked to submit administrator credentials. In this way, a user gives administrator credentials to a malicious process. That's why user account control is not a security boundary. It's simply an additional feature that can be worked into the structured protection model we've mentioned earlier. Its goal is to disable or hinder the automatic infecting of computers by programs that require administrator credentials.